Communication in a microcontroller. Right, what does this refer to? Thinking back to the block diagram of the microcontroller, we saw that it consists of the central processing unit, the RAM and the ROM, as well as the input-output peripherals. Alright, now the communication in the microcontroller refers to the transfer of data, logic 1s and 0s, from one of these internal devices to another. This can be done as either serial or parallel communication. Serial or parallel communication. In essence, what that means is we will have a sender, the device that is sending the information, and we will have a receiver that is receiving the information. The sender is one of the three devices, and the receiver is another device. So when it comes to the serial, we will have data traveling from the sender to the receiver 1 bit at a time for each clock pulse that is transmitted. When it comes to the parallel, however, we've got the same concept, sender and a receiver. We've got a clock that communicates between the two, or which indicates when data is being transferred, but instead of sending 1 bit at a time, it sends multiple bits at the same time in order to save time and increase communication speeds. Parallel communication uses more conductors. As a result, they're slightly more expensive than the serial, but it has the advantage of faster communication between the internal devices. The serial communication can be done as asynchronous or as synchronous communication. What that means is, in serial communication, there's a string of data that's being transmitted and received. In the asynchronous, communication, what happens there is the transmitter and the receiver does not need to be synchronized with each other by means of a clock pulse. The receiver only synchronizes when incoming data is being transferred. When it comes to applications or typical examples of this type of communication, we can think of a mouse or a keyboard. There is no data being transmitted, but as soon as I press a button or move the mouse, then data gets transferred and the receiver automatically picks up that there is data being transferred. How the synchronous works is it has the 8 bits that makes up the information. It also has an additional start bit and an end bit to indicate that information is being transmitted. The advantages of asynchronous is that it's cheaper compared to synchronous communication. Asynchronous transmission is better because line cost will be low and idle time is not expensive. In this approach, each individual data bundle is completed in itself. Therefore, if a character is corrupted, for example a bit is interfered with, it doesn't interfere with the surrounding information that's being transmitted. It's possible to transmit between the transmitter or the sender and the receiver at different bit rates. Transmission can start as soon as data is ready to be transmitted, and it's very easy to implement. The disadvantage is it's less efficient and slower than synchronous systems due to the overhead of extra bits and the inserting of gaps between buses. Successful transmission inevitably depends on the recognition of the start and stop bits, and these can be missed or corrupted. With the synchronous communication, it doesn't have start or end bits. The communication is aided by means of a common clock pulse that synchronizes communication between the modules. Due to the clock pulse being there, there's no need for the start or end bits. There's no need for gap or idle times, and as a result, high-speed communication is possible between the modules. The advantages is that information can be transmitted a lot faster, whereby we've got our bus of information and our different clock pulses will indicate when a new bit is introduced. There's no gap between individual data bytes. The disadvantage is it's more costly because of the additional line required for the clock. It requires a local buffer for storage at both ends to separate the individual bits and to put them together at the end. These can be seen in the shift registers. And finally, it requires an accurate synchronized clock at both ends.